Right. Welcome to the third lecture, I suppose. Yeah. So, what did we do last time? क्या discuss हुआ है?
Conditional probabilities हमने discuss की
Hmm.
how probability comes and how we assign value, and then we
So,
discuss conditional probability, intersection,
right.
dependent, independent. That's it.
So we started with layman terms, right? General terms for probability, and so we discussed that in details. I'll not go in the details, but I'll summarize. We said probability was lack of knowledge, right? And you know your height, but height of next person who comes in, lack of knowledge. Yeah. Why there are lack of knowledge? We identified four,
Yes.
at least four things. Future event hasn't happened yet. You haven't tossed the coin yet, so I don't know. Too hard to collect information. Yes, too many sensors, too much mathematics required, so it becomes too hard. Uh, Natural variations in events or things. Fourthly, quantum weirdness.
Quantum
Yeah,
weirdness,
so
yes.
the that issue currently it is at least considered to be naturally random. Nothing wrong with our instruments or our theories. Yeah, right. So, what was statistical analysis then? Or that was the process of trying to reduce this lack of knowledge. Yeah. So we don't know anything about the height of the next person, but we can do statistical analysis to guess, right? So why do we want to guess now? Because it helps us in designing and decision making. As I said, the height of the door has something to do with that, the size of the chair, the height of this table. Averages से linked है ना somehow. So that was a quick summary. Then we said, okay, how do we assign probabilities? So we wrote the ground rules, the constitution, process, and the rules there. Yeah. So firstly, what did you have to do? Clearly define your experiment. Why do you have to clearly define? Because the second step says define the sample space or the universal set or the set of all possible outcomes. Now, if your experiment is not clearly defined, you may miss some outcomes. फिर तो आप सारे जो start ही खराब हो गया ना, yeah. So this is very critical. First step is very critical. Then once you have clearly defined your experiment, you define the universal set or the sample space. Yeah. Then define your events of interest. Right. So you decide you clearly defined your experiment, and then you define your sample space. I'll be calling it capital omega, and in that you define your set of possible events. Could be any number. We will see details of these also, right? Continuous, discrete, all that it will come maybe in the next lecture. But for now, I just want to see. And one assumption I'm making is that these are simple events, meaning they are mutually exclusive, all of them. Yeah. Why? Because then I want to make from them compound events, right? So what you usually call events are compound, where simple event is also a subset, yeah, a possibility. So what was compound event? We said it's some omega such that omega meets some conditions, right? So you could say omega such that omega equals 1. Then if there is any one of them is 1, that is your event. Again, could be omega such that omega is even, omega is odd, omega is positive, omega is greater than 6, less than 7, whatever. Yeah. So this is the third step. Define your events of interest. क्योंकि events you can make many events on an experiment. What are you interested in? आप उससे निकालना क्या चाहते हैं? Yes. So identify events. Fourthly, what was it? Assign probabilities such that they make sense. Sense में फिर क्या आ गया था? What was their axioms? Right? What were the three senses we should make? Kolmogorov axioms क्या थे?
Greater than equal to 0.
So probability assigned to any event should be non-negative. Yeah, it should be 1. For sample space, it should be 1. Thirdly, what was it? If A and B are, for now I'll just write like this, then probability of A union B is probability of A plus probability of B. If they are mutually exclusive, we know that this set will have how many elements? Same as this and together. So if this is 3 elements, this is 5, it will be 8. The union will not repeat anything there. Yeah? So then basically the probabilities assigned to each one should be the sum of the two probabilities, right? So you do that in measure theory quite often. So it's like even distance measure करते हैं ना, right? So let's say there are two non-overlapping intervals, right? Let's say this is from here to here, this is A and this is B. Then if you say the length of A plus B, that length is a measure. Yeah, length of A plus B should be length of A plus length of B, right? अगर वो non-overlapping है, otherwise your length formula is wrong. Yeah, it makes perfect sense. So measure theory is, this is also measure theory, but in a probability domain, right? So we said this is the fourth thing, and this sets the constitution. We didn't assign any probabilities yet. Yeah, we just talked about it. Okay, what did we do next after this? We yeah, so we went from here to then talking about, let's say, multiple events interacting with each other. Right here already we had talked a bit about mutually exclusive events, right? But then we went on to say talk about multiple events interacting with each other, and if I follow the same order, one of the things we were interested in was two events happening at the same time. What do we call that? Joint probability. Yeah. So two events happening in the same time, there are many ways of writing it. This is PA and B, or PA intersection B. Yeah, and we wrote the formula for that also. What was it? PA and, or did we not write yet? We wrote for the conditional one in terms of this. Okay, so we will skip that. We can come back to this soon. Okay, so probability of A and B, two events happening at the same time. Yeah, so like let's say we have a projector and a screen here to give the presentation, right? What is the probability that both of them will fail at the same time? So I want to give a presentation, I turn this on, doesn't work, I turn that on, doesn't work. So probability A and B. Sometimes we are interested in looking at events happening at the same time. Yeah. Okay. Then we talked about by the way, what is P A union B then in words like this?
Probability of A plus probability of B.
No, not the formula. Like this is and
A union.
Probability of A or B.
Or B. Okay. Yes. Yeah. So one of them happening. Right. So rather restrictive कौन सी है? Which one is more restrictive?
Restrictive A intersection B.
A intersection B. Yeah, they're saying both have to have. This is more, ये हो जाए या वो हो जाए. In more cases, this will be higher. Yeah, because it's allowing more things to happen. Whereas this is saying नहीं दोनों ने इकट्ठे होना. That is usually less possible. एक ही situation में. Yeah. What did we go to next? Probably one of the most important concepts in basic probability, conditional probability, right? Conditional probability says, what does it say?
Reduce some lack of knowledge.
Yeah, reduce lack of knowledge, or we try at least, and we say, okay, one of the events has happened, right? Now what's the probability that other will happen? We did this in great detail last time. I'm just going through very fast just to revise the main ideas. So here, what's the difference? We discussed that difference is very critical. Yeah. What is the difference? Here.
Both happening at the same time.
Okay. And about this?
One is given and
one thing has happened, and
Mm.
on the basis of this, we're going to calculate the probability of A.
Yeah, and I like to see it also in this sense that here both are still open, both are still random, right? Probability of A and B. A happens or doesn't happen, still random. B happens or doesn't, still random. Here one is locked. B has happened. In a way, when you are writing this thing, you are saying B is no longer random. Whatever outcome it was has already happened. Originally it was random. There is a probability of B. Yeah. So we linked this with here. How is that?
It's lower probability of B.
B. Yeah. Condition what?
B probability of B greater than 0.
Yeah, not great. Yeah, greater than.
Greater
Cannot be
than.
negative. So, but we normally write like this. Is fine. So probability of B not 0. Yeah, because mathematically it's a division by 0, but we also saw something logical in there. What was the logical explanation? Why can't we allow PB to be 0?
क्योंकि सर वो उसके ऊपर डिपेंड ही नहीं करेगा जब अगर हमारे पास इसका इम्पॉसिबल इवेंट्स है सो देन वी हैव नो बेनिफिट्स ऑफ
Yeah.
इट इट्स
So
इम्पॉसिबल
not just benefit. Here you are telling me to find the probability of A given that B has happened. So you're giving me information that B has happened. And now when I ask you to tell me the probability of B, you say it was 0. It was impossible. So one of these two informations is wrong. Right? They're inconsistent. You're asking me, okay, what's the probability of A? As I tell you that B has happened. Now I say, okay, what was the probability of B happening? You say it was impossible. Then how did it happen? झूठ बोल रहे ना आप. You're lying to me. There's logical inconsistency. That also explains why you cannot have this. So, of course, mathematically it's the easiest to see, but logically also. We discussed that last time also. Yeah. Why did I say it's one of the most important things? Believe me, in real applications, in real life problems, it's the conditionals that we know most often. Okay? It's the conditional probabilities that are available to us. Okay, what is the probability that this will happen given that that person was going there? There is always some event, or most cases there is something, some information that is available, and based on that we want to assign probabilities. Okay, so what's the probabilities or chances of the heights of the next person coming in? Yeah. Now, what if I tell you that the next person coming in is a female? Okay, does it affect the probabilities of or the distribution of their heights? It does. Yeah. In Pakistan, I guess men are around 5'7" average. So if I tell you that it's a male coming in, then you have this probability distribution centered at 5'7". Yeah. Whereas if I tell you that it's a female, I guess average is 5. नहीं ज़्यादा average I don't think 5'2" से ज़्यादा होगी. Average female height in Pakistan. Then I'm also putting another condition that this is Pakistan. So in Sweden the average male height is 5'10", which is mine. I'm average there. Everywhere I see people taller than me. Here I am much above average. It's 5'7" or something. I checked long ago for Pakistan also, and their female average is this. Ours is 5'2", I think. I checked several years ago. So anyway, but as soon as you know that now the distribution or probabilities assigned to the height of the next person coming in, if you don't include, if you don't know it's a male or female, and from Pakistan for example, then you have to take the average of the whole world. Yeah, and everything comes in one, whatever the Pakistan, American, Italian, you combine all of them, whatever number you get, I don't know, let me just put 5.5 here. Yeah, this is all combined. But as soon as I give you some useful information, you become more specific. Yeah, so in most cases there is a lack of knowledge about some uncertain event, but then there is some information that we have that we want to push in to help you decide or conclude better. Yeah, सारा कुछ यहाँ mix हो गया, not very useful. अब इसको separate करते जाएं, मे बी जीके के स्टूडेंट्स की एवरेज हाइट्स निकालें और डिफरेंट होता जाएगा, राइट? सो that way we can reduce the lack of knowledge or help you reach a better conclusion. So conditional probabilities, as we said, A given B. And what did we say, what the conditional probability is actually doing here? क्या कर रही होती थी? What does it do to the universal set? So let's say, as I gave the example last time, I'm just repeating here. Let's say I write a number on piece of paper, and I tell you it's 1 2 4, 1 2 3 4, one of them. Yeah. So what's the universal set here? One of these, right? So what's the probability that I wrote 2 is 1 by 4, given as the assumption that I'm fair and not biased, so I always pick randomly, right? But what if I now tell you that I wrote a number from 1 to 4, but it was even? Yeah. What's the probability of 2 now?
1 by 2.
1 by 2. What did this second event do? What happened when I gave you this extra information?
It's reducing our lack
It's
of
reducing your, originally your omega was this, the universe of possibilities. Now it has shrunk the universe of possibilities. What happens when you reduce the universe of possibilities? You are moving
probability
towards,
will increase.
Yeah, increase, or you can be more specific,
Precise.
yeah, precise होते जाते हैं. Probability, you know, probability 0 and 1 are both very specific. ये 0.5 है which is problematic. 50% में मसला होता है ना, 0 में भी आपका एक तरफ झुका हुआ है, 1 में भी है. One thing is certain, the other is certainly impossible. Right? तो वो दोनों है. It doesn't mean it has to push you away from 0.5 actually. 0.5 is the pure random, कुछ नहीं पता, 50-50 chance है. Yeah. So what it does is it shrinks your universe of possibilities. Good information. Then there is information that is not good. Yeah. Like in this case, I say I wrote a number less than 5. Your universe is still omega. कोई फायदा नहीं हुआ. You'll be back to 1 by 4. Yeah. Or the information could be totally unrelated. I had 2 cups of tea this morning. अब कौन सा number लिखा? कोई फायदा नहीं. It doesn't shrink your universe of possibilities. Yeah. So I'm just quickly repeating because these are important concepts, and that's where statistical independence came in, right? When knowledge of one, let's say probability of A given B equals probability of A. What happens here? इसको आप आम अल्फाज में बता सकते हैं, simple words. What's going on? If this holds, then we say A and B are statistically independent. What do we mean here? What is it saying?
This lack of knowledge does not affect our event A. We have no benefits of this.
Yeah. So knowing B didn't do anything to the probability of A. वही है जो पहले थी, open वाली. Without knowing B and with knowing B, it's the same. फिर मुझे बीफ का फायदा क्या, जान के करना है क्या, उठा के साइड में फेंक दो. Useless है इस सेंस में. It doesn't help me. Yeah. So another way of doing it is to solve from here, and you will see that it also results in probability of A and B being separable in multiplication. Yeah. A intersection B is PA PB. This is a natural consequence of this, and then you put it here and you will get there. But this is, for me, this is the core, जिसके अंदर आपको logical reason नजर आ गई है. Yeah. What is the logical reason? As we said, if the probability of A with or without knowledge of B is the same, then B is not adding any statistical information or probability. So they are statistically independent. Orthogonal है उस sense में. Yeah, it's not giving me any information that will help me change the probabilities. Yeah. Okay. So now today, basically now we are at today's lecture, so we will keep it short, I guess, in the sense that new material will be limited. We had that philosophical discussion before about Munchausen and everything, and then this repetition, I think it's important a bit. But let's see. We'll build on some of this and then also come across two very important results, or for just like this conditional thing here and these things, there are two more things that I want to bring here. Yeah, before I, so then we are mostly done with the foundations of probability, whatever we needed. We will come back to more things, but we will see probabilities from perspective of random variables, random processes. Purely random probability theory, we will put it aside. Yeah. So uh, right, so let's say I tell you that I am designing an experiment, yes, and in that experiment I have identified that the universal set or the sample space omega is omega 1, omega 2, omega 3, omega 4, omega 5, omega 6. Some experiment. I'm not mentioning what it is. Then, and I tell you this, that omegas are distinct or simple events, meaning they are all mutually exclusive. Okay. So then, what is the probability of omega 1? Can you say something about it? सोच के बताएं, कुछ कह सकते हैं आप?
If they are unbiased and 1 by 6 events.
Unbiased, so by that you mean they have the same probability. What's the name for that?
1 by 6.
When events have same probability, what are they called? Equally likely. Yeah, so you are putting that assumption, exactly. Without that assumption, can you say anything here? No. There are two things you can still say. One is that it's between 0, it's greater or equal to 0. Second is it's less or equal to 1. ये तो कह सकते हैं ना, right? उसके अलावा you cannot say. To say the next thing, you need some assumption or some more information. Then you stop here. I have to then explain to you what is the experiment ताकि आपको ये कुछ कर. लेकिन if you say they are equally likely, then you can say okay, this is 1 by 6. Yeah, why? Because there are 6 mutually exclusive distinct events which are equally likely. Yeah, so if they are equally likely, then there are 6 possibilities. The universe size is 6 and I am interested in only one of them, so of course it's 1 by 6 if they are equally likely. So for equally likely, what do we have? P omega 1 equals P omega 2 equals P omega 3, P omega and 1 by 6. And does it meet the axioms in this case?
Yes.
It does, yeah? Because probability of this guy is probability of omega 1 union omega 2 union, all unions will be summed together 1 by 6 plus equal to 1. Yeah, all 1 by 6 times 6, 1 हो जाएगा. Each one is greater than or equal to 0, each one is less or equal to 1, all 3 axioms are covered. Yeah, okay. Now in case of equally likely, okay, this becomes interesting. Now let's say I have another example here, so I reduce this number, okay, and now I say, without telling you what the experiment is or without saying anything about equally likely or something, I say probability of omega 1 is 1 by 5. Okay, now what can you say? Are the events equally likely?
They are not equally likely.
Why?
So in simple space there are 4.
Yeah, so the axiom will be violated. Yeah, क्योंकि आप अगर equally likely करते हैं तो each one will be 1 by 5. 4 times 1 by 5 is not 1. Yes, less than 1. Something is. So from here at least we get the idea that it is not, they are not equally likely. Okay. What if I now add some information? I say omega 2 is 1 by 5 and omega 3 is 1 by 5. What is probability omega 4? Calculate करके बताएं जल्दी से.
maybe 2 by 5.
2 by
5.
5. Yeah, because whatever is left, you sum them up. Total should be 1.
One.
Why do we know that? Remember axiom?
Axioms.
Second axiom had to be 1.
1.
If you say no, everything is right and it is still not summing to 1, then your sample space is wrong, most likely. कुछ miss कर दिया आपने. कोई और भी outcome था which you thought was impossible, but it was possible. Yeah. So वो आपको check करना होता है.
It's quite natural that we toss a coin and we get a probability half-half. But is there a natural phenomena of tossing coin that we get some probability 1 by 2 and 1 by 8? कि मतलब इस तरह हमारे पास नेचुरली ये हमारे पास कॉइन का होता है ना, क्या हमारे पास कोई ऐसी भी हो सकता है कि हम टॉस करें और हमारे को 1 by 2 1 by 8?
Yeah, there are rigged coins which their material is एक तरफ जो है ना थोड़ा heavy होता है.
Yes.
You can have rigged coins, okay, but you have to go into the material science of that. वो फिर इस material और shape is not uniform. उसमें कुछ impurities add करके you can have it that it is heavy sided. It has one side which is more or less likely to appear than 50%. बिल्कुल होते हैं. Yeah. So and people जो in gambling people used to have them. अब तो यार पकड़े जाते होंगे, लेकिन yes, it is possible. But if you are not cheating by design, then the way they are made, the coins, there is no reason, physical reason for them to be more often coming on one side. Yeah. Design enter हो जाता है जब अंदर intentional design, then things become asymmetric. Yeah. Otherwise they are mostly symmetric सी रहती हैं. Right. ये जो planets वगैरह सारे जो गोल होते हैं, right, ये चौकोर क्यों नहीं होते हैं, कि कोने क्यों नहीं निकलते, right? Because this asymmetry would require some design part. बस वो घूमते घूमते सारी जगह से equal forces लग रही हैं, सब equal है, तो वो फिर equal क्या होता है, round ही बनता है. Yes, so that kind of thing. Now here, what can we say about these three events? Are they equally likely? These three.
Not equal. These three are equal likely.
These three are, not all four are equally likely, but we can say these three are equally likely.
Yeah.
There are no requirements saying all have to be equally likely. Yeah. So now omega 4 is not equally likely. It's not with as compared to the others. They are equally likely. Okay. Then we have seen mutually exclusive events already. We have seen, right? So let's say I go back to this thing, omega 5, omega 6, and I make two events on that. Events are A and B. This is event A, this is event B. Yeah. So this kind of events I've already mentioned, we call them. Do they have any overlap?
No.
Can they occur at the same time? If for A to occur, what has to happen? One of these has to happen. Then A has occurred. For B to occur, one of these have to, but they are mutually exclusive by the way we design omega. Yeah.
Yeah.
So if omega 4 happens, B and A cannot both happen. Yeah. Only B has happened. Yeah? So if omega 6 happens, only B has happened. If omega 3 happens, only A has happened. Yes. So similarly for omega 1, there is no overlap. So these are in sets, they are disjoint sets, non-overlapping sets. In probability, they lead to what? Mutually exclusive events. And as I asked last time, this interesting question: are mutually exclusive events dependent or independent?
Dependent.
They are
Dependent.
heavily dependent. Yeah, knowing one locks the probability of other at 0. As we have to move away from 0.5.
Yes.
Either way, that is useful information, right? So if you know one has happened, this other will. So if I tell you that B has happened, what is the probability of A? 0. They are mutually exclusive. हो ही नहीं सकता. तो वो भी certainty आ गई ना. This is very certain that it will not happen. Yeah. Okay. Right. So in that case we also write probability of A intersection B is 0. Yeah. So they are non overlapping, and I've written some examples here, but you know, if I roll a die, event A is even number, event B is odd number, then A and B are mutually exclusive. Yeah, so that is rather easy to see, so we won't spend too much time on that. But what happens if we make this thing interesting? We say that this is A, this is B. Yeah, are these sets disjoint now? No, right? So is there a possibility that they can happen at the same time, A and B?
Yes, omega 4 when is happening.
If omega 4 occurs, then A has happened
Yes, sir.
and B has happened. So there is पूरा नहीं होना होता, remember, क्योंकि तो they are mutually exclusive, पूरा होना भी नहीं है उसने कभी, right? They cannot. Sometimes students confuse that if all of these happen, then A has happened. No, no, no. Only one has them has to happen for A to be member है ना, उस A का कोई भी member activate हो गया तो A is done, right? So now what is probability A and B in this case? Is it 0 or not 0?
Certainly not 0.
It is certainly not 0, some probability there. So from mutually exclusive, which was easy, now we have gone to this thing, which is saying these are this is not 0. Okay. So let's see, in this case now it's no longer 0, that's fine. Then we have an interesting question, what is A union B? Remember, for mutually exclusive, it's even part of the axioms that it should be A plus P, B if A, B are mutually exclusive. Yeah? I'm just going to write MX mutually exclusive. If they are. If they are not, then what is PA union?
Probability of A plus
Mhm.
probability of B
Minus probability of intersection.
Minus
probability of
A
Intersection.
B. Yeah? Why this thing?
So
joint probability.
we can write probability of A into omega 1, omega 2 and omega 4, and in the sum of that case, and probability of B into omega 4 plus omega 6.
Yeah. So why do we have to minus this guy? In this case, since they are mutually exclusive, even if you use this formula, this will go to 0 and you'll be back to that formula. Yeah. So this is general. It applies to both mutually exclusive and non-exclusive. For exclusive case, this will become 0 and you'll be back to the axiom. But for the exclusive, sorry, not exclusive, this will be non-zero.
Yes.
Yeah. Why do we have to subtract the overlap? क्या मसला है, ओवरलैप ही क्यों माइनस करना?
Axiom 2 भी फिर satisfy नहीं करेगा.
क्या करेगा?
Axiom 2 probability of
Axiom 2 is for mutually exclusive events, so it doesn't affect here. This is for events that are not mutually exclusive, right? Why do we need to subtract the overlap?
Because it's happening on the both side actually. It's twice happening in A and in B.
Yes, when you count A and B, you have counted it
Twice.
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 So once you have to remove it, right? You
Yeah.
over in the intersection it will appear once,
Once.
but here it's appearing twice.
Twice.
दोनों दफा तो नहीं निकाल देना ना, right? ऐसा तो नहीं है कि आप कहें कि मैं एक सेट A ये होगा और B जो है वो सिर्फ ये होगा, दोनों से निकाल लें फिर तो काम खराब हो जाएगा. Yeah, so you have counted it here and you have counted it here. Okay, then take it out in one of them. Yeah, how do you find it? Where is the intersection? That is the point which was counted twice. So
Twice.
subtract it once. दो दफा गिना, एक दफा निकाल दिया, बात वहीं आ गई, वापस आ गई. Yeah. So in a way, can I say that it's almost like saying that you are doing omega 1, omega 2 and sorry, this is omega 3, okay, and then you are doing omega 4, omega 6. You're making disjoint sets here. Now this is what you are basically doing is, ये क्या है? Probability of A minus probability of A intersection B. ऐसे ही है ना? Yeah.
Yes, sir.
So this plus this, these together are now, these are disjoint sets. तो वो sum हो सकते हैं, right? So probability of A minus probability of intersection B plus probability of B. Why can I just simply add them using the axiom? Because now I made them mutually exclusive. There's another way. दूसरा क्या है?
यूनियन एंड इंटरसेक्शन को प्लस कर लें both.
No, there's one more way of making these disjoint. Yeah, that is, I say okay, I have omega 1, omega 3, omega 4, and omega 6. Right? So now what am I saying? Probability of A plus probability of B minus, still disjoint,
Yes.
leads to the same conclusion. So this is just to show you graphically what's going on. Yeah. So what you are effectively doing is remove the intersection from one of them. दोनों से निकालें तो क्या बचता है यहाँ पे? पता है क्या बचता है? Omega 1, omega 3 और omega 6. If you remove it from both of them, तो फिर तो मसला हो गया ना, वो बेचारे का क्या कसूर है? Yeah. So you have to take it out from one of them and they become disjoint. And then you sum them, whatever is left. So we know PA plus PAB, yes, that's thing. Okay, so let's do another interesting example. This will be the last one for today, and then we will yeah, one more after that, but we'll go through quickly. So let's do this example. And this example will lead to a very important formula in probability theory, which is built on conditional. As I said, conditional is very important, yes, and this formula is very important, yes, but it builds on conditional, so conditional is very important. आज आके वही कहानी है, yeah? Okay, assume that there is a system, कोई system है, yeah, and the system collapses if two of its distinct components alpha and beta fail. ठीक है, एक system है, can be a machine, can be a car, can be a country, कुछ भी कह ले, yeah. It has two distinct components, alpha and beta. If the two of them stop working at the same time, the system completely collapses. If only one of them fails, the system can still manage something. Yeah. So let's say now, if the probability that alpha fails is 0.01, okay, probability of alpha failing is 0.01. ठीक है, probability of beta failing, probability theory में बच्चे students are also often scared of probability courses. They say the question is this big and the answer is 2 lines. Yeah, सारा कुछ question के अंदर ही होता है. Yeah, so that's why it takes time to set up the question, because you're setting up the experiment and assigning probabilities to the components. Yeah, then you ask them some holistic question. So probability of beta failing is 0.005, and the probability of that beta fails if alpha has failed. If one of alpha has failed, then what is the probability of beta failing? We say, let's say we have given you this, okay, we have calculated based on some knowledge of our, and I ask you, okay, what is the probability of total collapse? Chances of total collapse, what are they? Yeah, I've already told you there is a system, it has two distinct components. The system collapses completely when both of them fail. Yeah, and now I've given you what's the probability that this guy fails alone. Yeah, 0.01. This guy fails 0.005. कौन सा ज़्यादा reliable है इनमें से? beta, कि उसकी probability of failing is much
Much
less.
less.
Yeah, good. Then I say probability that beta fails if alpha has failed. होता we know कि जी उस पे load बढ़ता जाता है. If beta fails, then we know for some reason it's a power system maybe that if beta has failed, there's definitely this guy is gonna handle more load. Eventually इसने भी जवाब दे जाना है. तो that is beta fails if alpha has sorry just the other way. Beta fails if alpha has failed is 0.01. We asked for this. Now this is probably the first proper problem of probability that I am telling you. So I will take you through the steps which are very useful to follow. Always write what is given in a summarized version and diagrammatically, jitna possible. It helps the mind. Second, in probability, always assign or define events. Okay. Then rewrite this thing in terms of events and that union, intersection, all that. Yeah. So यही है ना इसकी ABC क्या है? Probability of A, probability of B, probability A union B, probability A intersection B, probability of A given B. यही है. फिर एक होती है probability of not A, A prime. वो मैंने कराया complement. That's वो simple सी बात है. उससे interesting नहीं लगा. Right. So I'm going to define events. Yeah. One event I am going to define is क्या होनी चाहिए?
When alpha fails.
Yes. B is beta fails. Interestingly, you don't need a third event to cover all the information and the question. सब कुछ आ गया उसके अंदर. कैसे आ गया आप बताएं उस पे. Define the events first. Write whatever you have in summarized version and graphically whatever possible. Yeah, जितना कर सकते. Then define events that will cover the situation. कई दफ़ा 4 events define करते हैं फिर situation cover होती है. Yeah, here this is where students usually fail. They are unable to make the events क्योंकि it needs some imagination and some practice. वो यहीं पे फंसे रहते हैं, गलत event बना लेते हैं, फिर वो सारा सवाल ही गलत हो जाता है. Yeah, but in this case, now can I write all of those? You can help me. What is P of पहला क्या है? पहली information. How do I write it here? P of
conditional probability.
no, the first one. Alpha. The probability that alpha fails is 0.01.
Probability of A is
A,
equal to
yes. Now see, I'm skipping now all that. Everything will be now P, A, B, union, intersection, given. बस सब कुछ close हो जाएगा उसमें, right? P, A is
0.01.
what's the second information?
P of B is 0.0.
Okay, what's the third information? Easy है.
Probability of B given A
Is
0.01.
okay. What's the question in this?
Probability of A intersection B we have to find. Both fail
Probability
that
of
it
A
is intersection.
intersection B. Yes, very good. So what did we do? We rewrote all of that information. This came from a paragraph description. It became this. This was translated into
Set theory.
sets and events, sets and events. Yeah, and this is where imagination comes in. You have to. ये तो बहुत easy example है. Sometimes थोड़ी सी ना difficult किस्म की events define करनी पड़ती है. Right. So okay, that is what you are asked for. Yeah. So do we have any formulas for these kinds of things so far? So let's say for you can try different things, but beta fails if alpha has failed. Yeah. So let's say we ask ourselves this: what is the probability that A will fail if B has failed? Right. So let's also ask this one: probability of B failing given that A has failed. Let's say we are also interested in this. So how can we write this? Do we know any formulas that can help us?
Probability of A intersection B.
Probability of B
Sorry,
intersection.
this is A given B. Probability of A fails given B has failed. Yeah. So we have a formula for that. What is that?
Probability of A intersection B.
Divided by B. Yeah. Okay. Now, do we know anything about probability of A intersection B? Can we expand that any further? So for now, let's make space here and move this. So what is probability of A and B? Let me help you here. First time it's a bit hard to look at it, but or see what's going on. But what's the probability of B given A by formula? That gives me an idea. What is probability of A and B? Yes? Okay. That means I can say something about this thing. Yeah? I don't have this information by the way. Either nahi hai na? Given the nahi hai. To reach this I also need this information. But there is a trick I can do to get to this information. What is that? Probability of B given A and probability of A. Yeah? Do I have both of these?
Yes.
And
Yes.
yeah. So I can write it as probability of B given A times probability of A divided by probability of B. Now can I find, firstly when I solve this I find the probability of total collapse. Yes? What is that? A and B happening at the same time. So what is this? B given A, you will put this value here, and you will put this value here. But without actually putting the values at this point, what is, I can also find the reverse thing. What is the probability that A fails given that B has failed? Just based on this information. Right? Why? Because now I can solve this. कर सकते हैं नहीं solve. I can put this point 015 here. I can point 0.01 here and 0.005 here. I can get here. Now, why I have chosen this example or this thing, I want you to focus on this part. We remove this from here, yeah, and we look at what's going on in our formula. Probability P given A times probability A divided by probability of B. ये अब एक किस्म का, it's a new formula made up of some previous formulas. Yes, it is made out of two conditional probability formulas. Yeah, so this formula is very powerful, extremely useful. Okay, it even has a name, Bayes theorem. Yeah, what is it really saying? हो क्या रहा है इसमें? Interestingly, you are finding probability of A, right? Conditioned on something, but you already have probability of A. So why? What is going on? What's the difference? What is this formula doing? In words.
That is a conditional probability of
Right.
A when B has happened, and we have an information that if B has happened, B is happening where A has happened. So this information, this is both are inverse kind of inverse conditional probabilities.
Right. So they are converse of each other.
Yeah.
So let's say I start with probability of A. I know the probability of A happening. Yeah. But now I know that B has happened, right? And I have some information about B. I want to input that information, this thing. Yeah. This thing into the system, and my output will be A given B. So this is completely in the dark when we didn't know that B had happened. Yeah? But once we know that B has happened, we update our probability. Yes. So this is called priori, okay, or prior probability. Prior means before any other information came in, right? With information input in here, this becomes posterior. Posterior means afterwards.
Afterward.
Yeah, so in Bayes theorem we normally talk about prior
Posterior.
prior probability and posterior
Posterior probability.
probability. Sometimes we write a priori, a posteriori, but in simple English it's prior to information being fed in and after information had been fed in. And there are many realistic situations actually where we don't exactly know P, A and B. Okay, if we knew that, we'll just use that, right? What we know mostly is the converse, as I said, the probability of B happening given that A happens, yeah, and the probability of B. That is where the Bayesian formula comes in. This is Bayes theorem or Bayes formula. What is it saying? It's saying that if you want to find the posterior probability of A, given that B has happened, then what you need to know is what was the starting point, the prior probability of A, and you need to know what was the starting probability of B, and you need to know what were the chances of B happening if A had happened.
Posterior probability.
Okay, and we will see, and you can maybe we will not have too much time because then we'll go into probability too much. But if you read about we were doing COVID tests, and so often we know that this instrument is 90% correct, 10% it is wrong. Yeah, so that is, we're saying that it will say you have COVID, one of the way of being wrong. Yeah, let's say that one. You have COVID when you don't have it. Yeah, that is, what is the condition here? You don't have it. What is the probability that it says you have it? Yeah, that is, we have some information about that. Yeah, now let's see the reverse of that. It says that you have it. What is the probability that it's wrong? This is reverse of that. So often we know some conditional thing, okay, and we want to know the converse of that. Okay, so ये आप थोड़े से examples और पढ़ेंगे, you will get to the idea. But this is our friend Bayes theorem, and it is one of the most important things used in machine learning, information systems, all of them. They use Bayes theorem and the related formulas quite heavily. Okay, and it also leads to some philosophical discussion between definitions of probability. There is a Bayesian approach, there is a frequentist approach. It's a bit detailed. I won't go into that. That's not, we are in random processes, not probability theory. Yeah, but you can read up, and if you're interested, difference between frequentist definition of probability and the Bayesian. For our purpose, all we know is that here, this is a formula. It's very helpful in going from prior probability to posterior probability, with the idea that there is the converse of this is available. Yeah, and of course you need PB, and PB should not be 0. Just one moment. Take this one. Assalamualaikum. जी 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 ठीक था. अच्छा, आप उसको बंद करो.
सर ने बताई थी ना, वो कौन सी बुक बताई है यार सर ने?
एक कुबाशी, एक
वो ग्रुप में सेंड कर देना, ग्रुप बना लो.
डाउनलोड किए हैं तो
सेंड
दो
करना.
बुक बताई है और एक तो उसमें ज़्यादा कहा था कि ये पढ़ना.
हाँ, वो सेंड करेगा ना वासी को.
वो वाली भेजना है, दूसरे दोनों ही भेजना है.
दोनों भेज देना यार.
मैंने कुछ पढ़ा ही नहीं था यार.
हमने कौन सा पढ़ा हुआ है? ये सर जो पढ़ा रहे होते वही बातें. हाँ हाँ कर
हाँ, सारा डिफाइन कर दिया सर को.
So often the data available to us is actually in this form. Okay, that conditional. Okay, if that event happens, then what are the chances? Usually that is how the data is available to us, and the decision we want to make is, okay, now what if this has happened, what are the chances that it was originally, as I
Yeah.
said in this case, you know that if a person is not sick and your COVID test says they are sick, his chances are 10%. This is one direction here. The other side will be saying, okay, now it's saying for me I am sick. What are the chances that it is wrong?
No.
ये समझ है ना, उलट हो जाता है. It's very often that you have a lot of info data from one side. Then you need to make a decision. Okay, एक particular person के लिए is it wrong? कह रहा है ये कि जी test positive है. Is it wrong or not? Yeah, so then you go for these kind of things. So anyway, in this thing you find the total collapse and you also found the probability of A failing. वो आप values डालेंगे तो you will I will not solve it. It's 0.03. Okay, so Bayes theorem, Bayesian statistics, we discussed that. You start with probability and this. If you allow 5 more minutes, I'll finish this. आज का लेक्चर फिर हम अगले में है कुछ है तो नहीं क्लास है कितने बजे बस 5 minutes. Okay, so last thing we want to discuss, this is the example here. So and it will also lead to a law that I want you to cover. थोड़ा सा आप गैस कर लेंगे कौन सी रहेगी ये बेसिक चीज. बाय द वे बेसियन भी हो गया है, कंडीशनल भी हो गया, क्या रहेगा, एक लॉ है.
Fundamental law, total law of probability.
हाँ law of total probability. Yeah, so I'll quickly cover that. Suppose your team is to play a PSL match. Yeah, you have put your team in PSL, Pakistan Super League. Yeah, and you will be playing against one of the three teams is Peshawar, Zalmi, Quetta Gladiators, and Lahore Qalandars. Yes, and now your chances of winning from Zalmi are 0.05. Okay, and winning from Gladiators are 0.04, and your chances of winning from Qalandars are 0.1. पहले तो बताएं किसके खिलाफ आपका मैच हो तो बेहतर है. Qalandars? Yes, because your chances of winning against Qalandars are 0.1. Okay, now the question is this: what is your probability of winning a match? Chances of winning a match if your opponent is chosen randomly with equal probability. क्या chances हैं कि ज़ल्मे choose होगी? What's the universe now? Universe is just these three teams. Yeah, and we are saying they are equally probable. So 1 by 3, 1 by 3, 1 by 3. Because of the axiom probability, sum should be 1. Okay. So as I said, how do you start? This is just in words and something. Yeah, you start by defining events. Yes. Firstly, we'll name our team. Of course, उन्होंने नाम रखे हुए हैं तो we are in Topi. So let's call our team Topi Drama. Yeah. Okay, कुछ और भी नाम रखते हैं आप, कोई मसला नहीं, right? Okay, so we define an event W that drama wins. ठीक है? Why this event? Because question है ही इसके गिर्द ना, winning, you winning, यानी your team now you named it Topi Drama, so drama wins. Yeah. Okay. Let's define another event that Zalmi is chosen. Okay, similarly G means gladiators are chosen. Yeah, and Q means Qalandars are chosen to play with you. Now, if I want to write this information now in terms of these events, can I write it?
Yes, sir.
What is it? What is this saying?
Then from sure.
Probability of
W
W
given
Z, yes, is 0.05. Probability of W given G is 0.04. Probability of W given
Q.
Q is
Point.
1. What else do we know?
total.
They are equally likely
Yes, sir.
to be chosen. So what does that mean? Probability of Z equals probability of G equals probability of Q, and that's the total universe. So it should be 1 by 3. Right? This is what we know. What do we have to find now? उसका लिखें probability की terms. What do we have to find?
Probability of W we have to find.
Interesting है ना?
Yeah.
Win की probability निकालनी है. अज्जा की है. You know, अच्छा उससे खेला तो मैं ये हो जाएगा, उससे खेला तो if I play that guy I'll win with this. अगर if that person is chosen and the chances of me winning are this much. So you know the components, but total नहीं पता समझ आ रही. Before they are chosen, yeah. What is अभी इसमें तो कोई condition नहीं है ना कौन choose हुआ है. Before they are chosen, that's your probability of winning. क्या होगी? कैसे निकालेंगे? जी.
Probability of W. इसमें सर हम सबका देख लेंगे ना कि मतलब जमी से विन करने की क्या प्रोबेबिलिटी थी हमारी.
So
G
let's
से
say
win करने की क्या probability.
exactly, but let's put it logically, yeah. In what situations can you win? आपका win जो है वो कब किन किन सूरतों में possible है?
कलंदर से.
Okay, play Zalmi and win. और क्या possibility?
Play
कलंदर and
Play Kalandars and win. और क्या? Play
कोयटा and
Koita and win. अच्छा अब इन तीनों में तो होना ही होना है. इनमें से एक होना है या नहीं? मिसिंग तो नहीं है कुछ. तो या तो आप कहनी मैं नहीं खेलते, भाग जाए टोपी ड्रामा, घर भाग जाए, the team runs away, yeah. That's not hopefully that's not going to happen. So one of these has to happen. Now the end part is conditional. We don't know, yeah. So far does it happen? So can I say probability of W is probability of also are they mutually exclusive? These three?
Yes sir.
है ना? Either you play Zalmi or you play Koita और तीन दोनों मिलके तो नहीं टीम बना लेंगे आपके खिलाफ, right? So they are mutually exclusive, so I can sum them, yeah, simply. But what am I summing? Probability of winning is I play Zalmi and I win. I play Kalandars and I win, and sorry, not given, and, yeah. Here is and here, yeah? And I play gladiators and I win. These are the three possibilities, yeah. Now do I know these?
Yes sir.
No, I don't know these. याद है हमारे पास ये है. Probability W given Z. We don't have the and. But is that a problem, or can we do something about it?
Conditional से find कर लेंगे.
Conditional. So we bring in conditional. We say okay, we know that this means probability Z and W given probability, or we can write sorry, and to already had probability W winning given Z time probability of Z. ऐसे लिख सकते हैं इसको या नहीं? लिख सकते हैं ना? Plus probability of winning given Q times probability of Q plus probability of gladiator winning given that we play gladiators times probability of gladiator. Now do we know these?
Yes.
ये तो है, right? We have this. Chances याद है हर एक के थे. And we have this also because of equally likely and the mutually exclusive thing. Plus also puts mutually 1 by 3. You can put it here and you can tell me the probability. This is actually a very general result. Okay, this is the law of total probabilities or the total probability formulas. What it is saying, that the total probability is the sum of all possible mutually exclusive situations that are in your favor. यही किया ना हमने. We wrote all possible mutually exclusive events that were in your favor. They had to be mutually exclusive, and एक और condition थी. They had to cover the universal set.
Yes.
अगर आप एक टीम छोड़ दें और फिर कहीं आप टोटल में निकाल तो गलत हो जाएगी ना. Yeah, they have to cover the universal set. Why am I saying that? Because then this is the general formula that I want to write from here. ये तो एक example है ना, बस formula लिख के we are done. We say that if there are events, if a case, event A1, A2, A3, A4, something like that, if a case are mutually exclusive events and they span omega. ये इसका क्या होता है? Spanning omega. ये वो मैं कह रहा हूँ. It should be
Yes,
the
sir.
whole universe. Together they should form your universe. Sets में that means spanning, and in simple notation we can write union over k of all a k is omega. ये union like summation होता है ना, इसका union का भी एक तरीका होता है लिखने का. ये UK means A1 union A2 union A3 करते करते वो should be, so it should span the universal set. If something is missing, you cannot use the formula I'm going to write, because then you not cover the totality of then PB is summation PB given AK times of AK over all K. यही हमने किया था ना. ये देखिए,
Yes, sir.
ये हमारे AKs हैं. Yeah, they span the total universe of set and they are mutually exclusive. ये भी important है, वरना वो sum नहीं कर पाएंगे आप. Remember, sum वाला part fail हो जाता. Then this is total and extremely useful again. Okay, because often we know parts of the probabilities, but then we want to find the total one, right? So we are done. आप जाने तो चले जाए, बाकी अभी कोई questions हैं किसी के तो हम discuss कर लेते हैं. I guess we have discussed thoroughly. We can also see next time at the start of the next lecture, or you can visit me in between if you have any specific questions. Yeah, right. So thank you.